Hello and Assalamualaikum. Today we are going to learn about new section in the same chapter. So this new section is about linear differential equation right here. Right. So we have learned about linear differential equation, but in this section we will learn more. We learn more about the linear differential equation. So the meaning or the definition of linear differential equation will be detailed in this section. And also we will learn about previously we have learned linear differential equation for the first order of differentiation, but in this section we will learn about the second order and the third order of the differential equation or differentiation. Okay, so we go to the subtopic, the subsection, which is 10.8.1. So we will learn about differential operator. If we go to the section 2.2, so you will learn about how a function works. So if you go to that section, you will learn something drawn like this. So you will learn about how a codomain right here, a domain is converted into codomain via a function. Alright. So a function, an operator. When we talk about differential operator, the difference between an operator with a function is actually an operator is a function, but if you look at here, an operator is a function that transforms one function into another function. So do you understand? So if you look at this diagram, so set A contain numbers of functions, or a set of functions. So it can be 10 functions, and set B is the outcome, another function created when functions in set A going through a function, and then it will create a new set of function. So the set A and set B has different functions. Alright, so what we call this is the operator, because it change one function to another form of function. Okay, so that is what operator all about. Okay, so for example, we have a function right here, and we have psi as an operator. So we can make the function going through an operator like this to create another function. So we will create a new function by taking this function going through the operator, and we get another function. Okay, so we go straight to the first example, this one. So we want to learn about how an operator works. So we have a form like this, where one function is going through an operator, which is actually a function as well, but an operator, like I said, is a function that change one function into another form of function. So this is another form of function created by the operator. So do you see what is the difference? the difference is the original function is squared. So that is the use of the operator. It squared the function, this function, and we will get the new function right here. Okay, hopefully you understand that. So when I want to put this function into the operator, so what will happen, it will change this function, this particular function, into a new function. So what will happen is, this is the new function created by the operator. So actually what happened is we square this equation, so we will get this one. Okay, so you can try that if you want to confirm. And also the same operator again, but different function. So we use the different function, sin t minus t. So when it goes through the operator, we will get a new function right here. Again, we square this one. Okay, hopefully you clear. So now we can go to the next example. Okay, if you look at here, this one is quite simple operator, but the one right here is more complex. Okay, do you see the difference? If you look at here, there is only one f in the operator, but in this new operator, we have several two f put in the operator. So an operator can be like this. So we can put multiple function in an operator, in several components of the operator. Okay, so when we have this kind of operator, and we know that this operator exists, so when we saw any function that has a similar form, for example, this function, can you see the similarity of the form between this one and this one? So if you look closely, we have this one, we have t right here and t right here, and we have 4 right here and 4 right here, and also negative, the negative, and we have t square, and at the third component right here, there's no f in the component. Okay, so we can see that some similarity appear, and we can relate and we can simplify this function in terms of the operator. So we will get this one as the answer, where actually this function is the outcome of the operation of the g square. So if you look closely, we have square right here, but we have 4, power of 4 right here, and we have no power right here, and we have power of 2 right here. That's why we have square right here. So that's why this equation is g square going through operator psi, this one. Okay, there's another example. If we found this equation, if you look compare between these two equations, we can see the similarity, and we can know that, we can simplify, and we can know that this equation is actually e power of t going through operator psi here. Okay, So that is the simplification of the complex equation like this into the simple operator right here. Okay, hopefully you understand that. Now we can learn about what is differential operator. So you know that an operator is changing one function into another function. But we know that differentiation also change one function into another function. And the another function is actually the derivative of the original function. Right. So we can call differentiation as an operation. And we can call this differential as an operator. Right, because this differential change the function within it into another function. So we can call it an operator. And in this particular case where differential involved, we call it differential operator. Not just an operator, but differential operator, because it involves differentiation process. Okay, that is differential operator. So we can again try the example 10.25 in order to understand. So if you look at here, this is a simple differentiation process. So this is the operator. So we call this operator as differential operator. Okay, because it differentiates any function going through the operator. So it differentiates the f function right here with respect to t. Okay. So simple. If we put a function t square, for example, in the operator, the outcome will be 2t. When we put sin t, the output of the operator is cos t. So it's like differentiation, but we use operator instead of differential form. Okay. And same goes to if we put this function inside the operator, we will get this one. This is the answer of the outcome of from the operation within psi operator. Alright. So next we go to the next example, 10.26. So let's say operator L. Now we change the symbol. Instead of psi, we use L. So operator L has this kind of function. So again, this one is example of simple differential operator, and this one example of complex differential operator. So even though we have so many derivative or differential, and even we have the second order of derivative, we still can consider all of this as one operator. Okay. So in this case, we have this kind of equation. Okay, so when we know this, okay, let's put it aside first, and then we found another function which has similar form with the operator L. Let me erase some of this first. So when we compare these two equation, this one and this one, so we can see the relation between these two equations. So this is another equation we found anywhere, and we can see that there's some similarity. This is second order, this is sine, second order sine. We have exponential, but the only difference is this term. Therefore, we can simplify this equation in terms of the operator L. So what will happen is we will get this answer. Okay. Y equal to t power of 4 because the similarity is only at the left hand side. So this one is similar to this one, but at the right hand side there is no similarity. Therefore, we have this one is the operator L equal to t power 4. Okay. So actually, if you look at this equation, the arrangement is the standard arrangement, where at the left hand side right here, we only put components where the term of dependent variable occur. I mean, term of dependent variable only in the left hand side, and any term or component that is not related to the dependent variable, we put it at the right hand side. So so if you look at here, if you look at this equation, the dependent variable is f. So if you look at here, the function f is placed at the left hand side there, and there is no function f at the right hand side. And if there is additional component which is not related to f, we put it to the right hand side, which is this one, t power 4. Okay, hopefully you understand that arrangement. So when we arrange like this, so this is the standard arrangement, so we can know whether the equation is homogeneous or non-homogeneous. So again, this is a linear differential equation. So linear differential equation can be either homogeneous or non-homogeneous. So when, in this case, when operator L is equal to 0, where there is no component at the right hand side, which is if you look at here, there is no t power of 4. So the differential equation is homogeneous. And when there is some equation at the right hand side, we know that there is non-homogeneous linear differential equation. So I hope you get that. So that's all for now. Thank you.